Now that you have understood uniform circular motion and centripetal force, watch some more videos on centripetal force.
Imagine you've got a tennis ball attached to a piece of string, and you start swinging it in circles. Whoa now, watch out for your buddy. Let's take a closer look at the fascinating physics of this simple action. You've probably heard of Newton's second law of motion as it relates to objects moving in a straight line. Turns out, Newton's second law also tells us about the net force on an object as it moves in a circle. When an object moves in a circle, its velocity changes direction. Since the velocity is changing, that means we have an acceleration. And we know from Newton's second law that if we have an acceleration, we have a net force. Now back to our spinning ball. For objects undergoing circular motion, the net force on the object is called the centripetal force. It's a weird-sounding word, but it's Latin for the phrase center seeking. It's named centripetal because the centripetal force always points to the center of the circle. The ball has a tangential velocity, so if you suddenly cut the string, it would fly off in whatever the tangential direction was at the moment you made the cut. But assuming you don't cut the string and you keep swinging the ball's tangential velocity is constantly changing directions. This means the ball is accelerating, and the reason it's accelerating is due to the centripetal force. The centripetal force acting on the ball is constantly directing the ball towards the center of the circle, your hand. This, combined with the ball's velocity, keeps the ball swinging in a circle. The same centripetal force that keeps the tennis ball swinging in a circle also keeps roller coasters on the track as they go through a loop-de-loop. So the next time you're having a blast on a roller coaster, you can thank the centripetal force.
Students, I have already explained you that the magnitude of centripetal force is given by the formula F is equal to mv square upon r. There is one more formula for the magnitude of centripetal force, and it is obtained by using Kepler's third law of planetary motion. How is this done? Watch in this video.
Force. Consider an object moving in a circle with constant speed. We have seen earlier that such a motion is possible only when the object is constantly acted upon by a force directed towards the center of the circle. What is this force called? This force is called the centripetal force. If m is the mass of the object, v is its speed, and r is the radius of the circle, then it can be shown that this force is equal to F is equal to mv square upon r. If a planet is revolving around the sun in a circular orbit in uniform circular motion, then the centripetal force acting on the planet towards the sun must be F is equal to mv square upon r, where m is the mass of the planet, v is its speed, and r is its distance from the sun. The speed of the planet can be expressed in terms of the period of revolution, t, as follows. Speed is equal to distance travelled upon time taken. The distance travelled by the planet in one revolution is equal to perimeter of the orbit 2 pi r. R is equal to distance of the planet from the sun. Time taken is equal to period of revolution equals t. Now v is equal to distance travelled upon time taken, which equals 2 pi r upon t. F is equal to mv square upon r, which equals m into 2 pi r upon t whole square upon r, which equals 4 m pi square r upon t square. Multiplying and dividing by r square, we get F is equal to 4 m pi square upon r square, which equals r cube upon t square. Now, according to Kepler's third law, T square upon R cube is equal to K. So, F is equal to 4m pi square upon R square K. But 4m pi square upon K is equal to constant. Therefore, F is inversely proportional to R square. Thus, Newton concluded that the centripetal force, which is the force acting on the planet and is responsible for its circular motion, must be inversely proportional to the square of the distance between the planet and the sun. Newton identified this force with the force of gravity and hence postulated the inverse square law of gravitation. The gravitational force is much weaker than other forces in nature, but it controls the universe and decides its future. This is possible because of the huge masses of planets, stars, and other constituents of the universe.
Now answer the following questions. Question number 1. Write Kepler's laws of planetary motion. Question number 2. Define uniform circular motion and centripetal force. Question number 3. Using Kepler's third law of planetary motion, obtain the formula for the magnitude of centripetal force. So students, here we end this chapter, chapter 1, gravitation. I have tried my level best to explain the contents of this chapter. In case of any difficulty and any queries, feel free to contact me. So stay at home, stay safe and enjoy studying. Thank you.